Hi Grade 8! I am Teacher Joshua, your mathematics learning guide here at DepEd TV. Do you still remember how to get the solutions to a linear equation in two variables? Can you still recall the basic knowledge on how to draw a line? This time, let's discover one way to describe the linear equation in two variables on the rectangular coordinate system. Join me in new chapters of learning that would help us be critical and logical thinkers. We will use the skills we acquired to take a larger scale of view. Make sure that you have your self-learning module, paper and pen, and let's get started. Have you been to Baguio? Or went up a hike on Mount Pulag or Mount Apo? They have a saying that the higher the climb, the better the view. And all hard work is worth it when you reach the top. But the height of the climb is not what makes it difficult, but the steepness or what we call the slope. Now let us look at the following illustrations. Which of the following do you think is more difficult to climb? Which will make you more tired? If you can see, even though that they have the same height, it will be quite hard to climb up the first mountain due to its steepness. And this can also be shown using a linear equation in two variables. First, let us define the slope as a mathematical concept. The slope of a line is the ratio of the vertical change between 2 points to the horizontal change between the same 2 points. The vertical change is referred to as the rise, and the horizontal change as the run. In symbols, the slope m is equal to the rise over the run. Now let us have some examples. Here are two illustrations of cars driving uphill and downhill. Again, we can show this as lines on the Cartesian plane. Let us take this one first, by making the road past the origin since we are just representing and we are not given exact coordinates. Remember that the slope is the ratio between the vertical and the horizontal changes of 2 points on the line. So let the point 0, 0 be the first point, and the second point on, let's say, at 6, 4. Now let us count how many units is the change in position. First, let us count vertically. From 0, we will count 4 units upward. This signifies that the vertical change is positive 4. How about the horizontal change? We will count 6 units to the right, meaning the run or the horizontal change is positive 6. Now, we have the slope m equal to the rise, positive 4, over the run, positive 6. And this can further be simplified as 2/3. Now, how about this one? Let us say that the road can be represented by this line. What do you notice? Remember last episode that we talked about the x and y intercepts of a linear equation. The x-intercept is the point where the y value is 0, while the y-intercept is the point where the x value is 0. It is easy to determine the slope given these points. So starting from any point on the line, let us say here at -4, 0, let us count how many steps or units we need to take to the next point at 0, -3. Be mindful also of the direction that we go, since the signs depend on it. So we start vertically with 3 units downward, then 4 units to the right, which means the slope m is equal to the rise -3 over the run positive 4. Therefore, the slope of this line is -3/4. Observe that visually, a line rising from the left to the right has a positive slope. and the line falling from the left to the right has a negative slope. This can help you recall the slope given its graph. What about the slope of a horizontal line like this? Let us take 2 points, 2, 1, and 5, 1. Now, are there any vertical changes in its position? There are none, so the rise is 0 units. And for its horizontal change, it is 3 units. Hence, the slope is 0 over 3 units, which simplifies to 0. Thus, the slope of the horizontal line is 0. Now that we know the slope of a horizontal line, it is mandatory to learn the slope of the vertical line. And I think the next method might be helpful. Let us say that this is our vertical line. Remember that a point is given by a unique set of coordinates x, y. So given any 2 points on the line, we can mathematically solve for its slope. It does not really matter which point will be the first in our equation. But for the sake of this example, let us say the first point, x sub 1, y sub 1 is 3, 5. And the second point, x sub 2, y sub 2, has the coordinates 3, negative 2. Now, remember that the slope is equal to the rise over the run, or the vertical change, over the horizontal change between 2 points. We can compute for that change by subtracting the respective coordinates. So the slope can be represented by m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, or y sub 1 minus y sub 2 all over x sub 1 minus x sub 2. So substituting the values in the equation, m is equal to negative 2 minus 5 all over 3 minus 3. Can you simplify the expression? We will have a slope m equal to negative 7 over 0. But wait! Remember that dividing by 0 is undefined. So where does it leave us? The slope of a vertical line is undefined, since there is no horizontal change between the points on the line. Let us now try to find the slope of the line passing through the points 4, negative 1 and negative 2, positive 5. So we assign the coordinates the respective variables. Now, the slope m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. By substituting the variables, we will have 5 minus negative 1 all over negative 2 minus 4. Can you perform the operations in the numerator and the denominator? Indeed, it will be positive 6 over negative 6. And further simplifying it will give us a slope of m equal to negative 1. Now try this on your own. Find the slope of a line passing through the points 7, 4 and negative 2, negative 3. Again, it does not matter which point will be taken first, but be mindful of the position of the terms in your equation and their signs. So, do you have an idea about the slope? We can have m equals negative 3 minus 4 all over negative 2 minus 7. After performing the operations in the numerator and the denominator, our slope is equal to negative 7 over negative 9. Or simply, 7 over 9 by dividing negative 1 on both numerators and denominator. Note that the slope of the line can be positive, negative, 0, or even undefined. In our previous episode, we talked about the standard form of the linear equation in two variables, ax plus by equals c, where a, b, and c are real numbers, and a and b are not zero at the same time. We can find the slope of this line by selecting 2 points or solutions and using the previous formula. But that will take a lot of time in substituting and computing for the necessary values. What we can do is to transform or write the equation in another way called the slope-intercept form, or y equals mx plus b, where m is the slope and the small letter b is the y-intercept. Remember that the y-intercept is solved by letting x equal 0. But we will not compute anything here, since we will just be rewriting the equation. So let us have the equation in standard form: 2x plus 5y equals 4. To write the equation in slope-intercept form, we must express y in terms of x, or isolate y on the left side of the equation. So in this example, we can apply the addition property of equality by adding negative 2x to both sides of the equation. Or simply, 5y equals negative 2x plus 4. Then we divide both sides of the equation by the numerical coefficient 5 and simplify. Therefore, the slope-intercept form of the equation is y equals negative 2 over 5x plus 4 over 5, or 4/5. Furthermore, the slope is the new coefficient of x, which is negative 2/5, and its y-intercept is b equals 4/5. Let us have another example. Find the slope and the y-intercept of the line whose equation is y equals 2x minus 3. What can you tell me about the equation? It is already in slope-intercept form, so we just need to identify the needed values. What is the slope? The slope is positive 2. How about the y-intercept? The y-intercept is negative 3. Let us have this last example before we move to the evaluation part of our lesson today. Write the equation of the line negative 9x equals 6 minus 3y in standard form and in slope-intercept form, then find its slope. Remember that the standard form is given by the equation ax plus by equals c. So by applying the addition property of equality to move the terms, what will be the standard form? We will have an equation negative 9x plus 3y equals 6. What do you notice in this equation? There are two things I would like to point out. First, the leading term is negative. Second, all the terms in the equation are divisible by 3. So we can still simplify the equation by dividing both sides by negative 3. We will have 3x minus y equals negative 2. Next is we write the equation in slope-intercept form. By the addition property of equality, we could add negative 3x to both sides of the equation. And we will have 3x minus y equals negative 3x minus 2. This will yield a new equation, negative y equal to negative 3x minus 2. But take note, we should have a positive y for the slope-intercept form. After multiplying both sides of the equation by negative 1, we will have the slope-intercept form of the equation y is equal to 3x plus 2. Now let's answer the final task. What is the slope? The slope is the numerical coefficient of x, which is 3. Were you able to understand our lesson for today? Because we were able to find the slope of a line in 3 ways. So let's take a recap on everything that we encountered in this lesson. The slope of the line, m, is defined by the ratio between the vertical change and the horizontal change of 2 points, or the rise over the run. Given the graph of a line, we can determine the slope by selecting 2 points on the line and counting the number of units upward or downward for the rise, and counting the number of units to the left or right for the run between the 2 points. We can also find the slope given 2 points without the graph. We assign the coordinates x sub 1, y sub 1, and x sub 2, y sub 2 to our points. Then solve for the vertical and the horizontal change by getting the difference of the coordinates, or m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Lastly, we can also get the slope of the line by writing it in its slope-intercept form. Y is equal to mx plus b, where m is the slope and b is the y-intercept of the line. This can be transformed using the properties of equality that we know and expressing y in terms of x. Now that we have finished the lesson, it is important to evaluate and see what you have learned. So make sure that you have your paper and pens with you. I will give you 5 seconds to answer each item and write the letter that corresponds to the correct answer. Number 1. Given the equation y equals 1/3 x plus 2, what is the slope? Is it A, 1/3, B, 1, C, 2, or D, 3? The correct answer is letter A, 1/3. Remember that in the slope-intercept form, the slope is the numerical coefficient of x. Number 2. What is the slope of the line given by this graph? Is it A, -4, B, -2, C, +2, or D, +4? The correct answer is B, -2. Note that a line falling from the left to the right has a negative slope, and you must always write the answers in its simplest form. Number 3. Describe the slope of the line passing through the points 2, -3 and 8, -3. Is it A, 0, B, positive, C, negative, or D, undefined? The correct answer is A, 0, since the change in y is 0, and 6 for the change in x. Number 4. When is the slope of the line undefined? A, when the line is diagonal, B, when the line is horizontal, C, when the x coordinates are the same, or D, when the y coordinates are the same. The correct answer is C, when the x coordinates are the same, since the denominator of the slope or the run will be 0. Last number, find the slope of the line whose equation is 2x plus 4y equals 6. A, -2, B, -1/2, C, 1/2, or D, 2. The correct answer is letter B, -1/2. We can get the slope by writing the equation in its slope-intercept form. Y equals -1/2 x plus 3/2. There are also formulas or other shortcuts to get the slope given the equation, but I'll leave them to you to discover. How was that exercise for your minds? Remember everything that we learned today because all of this will be useful in our next lesson. Math is everywhere. We may not see it right away, but keep on practicing with the exercises on your self-learning module and you will be masters of math in no time. You can also visit the DepEd TV official YouTube channel to watch and review our episodes and lessons. Next episode, we will graph a linear equation in 2 variables. So prepare your graphing paper, ruler, and colored pens for our activities. With that, this is Teacher Joshua reminding you to practice, 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 and do it with a positive attitude and a smile on your face. See you again for a math terrific day. Because here at DepEd TV, we will never let your learning hindered by anything.